The first part is quite straightforward, that's why only worth 1 mark. And then basically it's based on what here and then build up the items that we need. For example, we have 64 divided by v. It seems like we swap the denominator here and also the numerator here. So 64 both sides divided by v and then both sides times the denominator. And then you realize that 64 over v minus 4 are talking about this term. And you find natural log here, that's why you take natural log on both sides. That's why we have natural log h and then plus natural log e power of kt equal to this item. And 64 over v minus 4 natural log is equal to kt plus natural log h. We say this item is a linear function of t. That implies k here is the slope. If our asset is t and natural log this item, and then natural log h, this constant represents the vertical intercept. That means if a line is like this, then the slope here is equal to k while the intercept here is natural log h. In part B, they say that this line is passed through the origin. That means pass through O here. So we update the information, it should be like this. But at the same time, that means 0. Natural log h is equal to 0. And pass through 2, 1. So 2 here, 1 here. So it should be upward sloping rather than downward sloping. To be more precise, pass through origin, that means when our input equal to 0, then our output, the whole item here, is equal to 0 also. So if we substitute it, we know 0 is equal to k times 0 plus natural log h. It supports the finding that just now natural log h equal to 0. So both sides perform opposite of natural log, that means e power of something, e power of 0. So h is equal to 1. And second point, they say that pass through 2, 1. That means when our input here is t equal to 2, then our output, that means natural log 64 over v minus 4, will equal to 1. Again, we substitute that 2 item, and then we get 1 is equal to k times 2, and then plus natural log h. Well, we already know natural log h is equal to 0, so this part is negatable. K is equal to 1 over 2. Now, we are going to differentiate. Before we really take action to differentiate, we better rewrite it in the format that more favorable in our calculation. So v is equal to 64 and then h e power of kt plus 4 power of negative 1. It's more favorable in our calculation, and we already know h and k, so 64 h is 1, e power of 1 over 2 times of t, and then plus 4 power of negative 1. And then it seems that it's good enough. We differentiate now. 64 is a constant, and then we have a power of negative 2, and then we differentiate that, still the same, but by the chain rule we still have to differentiate the power here, so it's give 1 over 2. Tidy up a little bit, negative 32 e power of 0.5t, and then we have e power of 0.5t plus 4, and then power of negative 2. You may also write in this format, you will feel more comfortable. So and then the last part, we have to find the value of v when this condition is very important. When this item attains its least value, that means we have a bottom like this. That's why at that point the slope is equal to 0. So we are talking about the slope of this item equal to 0. This condition, that means differentiate this item equal to 0. So don't mix up, we are not talking about this one equal to 0. We are going to differentiate once again to consider the second order of derivative. So we are going to differentiate once again. Negative 32, prepare a bracket so that you can isolate it with the negative 32 here. We differentiate the first one, is give e power 0.5t times 0.5. And then we keep the second factor. After that, we keep the first factor. We differentiate the second factor. We have negative 2, and then the whole thing power of negative 3. And we differentiate that. So we have this item. This part and this part are the same, so we can extract it as a common factor first. Therefore, we have negative 32 times 0.5, it's become negative 16. We have this bracket, power of negative 2. And we have negative 2 times of this term and then bracket. It's always better for you to separate your calculation step by step, even you realize that there are multiple common factors. But I strongly suggest you to extract one by one, and so that you can concentrate in each operation. Of course, the next step, we are now extract the factor, and we will choose the least power. The least power here means power of negative 3. So from the first term, bracket power of 1 will be left. And then the second term, only this part will be left. (16) e power 0.5t and then e power 0.5t minus 4 divided by e power 0.5t plus 4 power 3. We finish our preparation work to evaluate this condition. We are going to evaluate when dv dt attain its minimum value, least value. So after we get the second order, we still need to find out at which point what is the corresponding t to make it become 0. When dv dt attain its least value, which means that second order derivative is equal to 0. That means 16 e power 0.5t, e power 0.5t minus 4 over this item equal to 0. So both sides multiply denominator. We just need to focus on this equation. Our conclusion is e power 0.5t equal to 0 or e power 0.5t minus 4 equal to 0. However, this is impossible. It can't be 0, must be some positive, so we reject it immediately. So we get the corresponding t to fulfill this condition. When t is equal to this value, then most probably this one attains its least value. But however, it's not confirmed. Maybe at this point it's obtained the maximum value here or here. In order to distinguish this, that's why we need a table. T, this timeline is cut by a single point for natural log 2. That means left hand side, this is the range that t between 0 and smaller than 4 natural log 2. Right hand side is t larger than 4 natural log 2. And below we are testing the slope of the dv dt. That means the second order derivative. Just now we calculate that this part will give you 0 slope. That means a flat point. And then if you have enough time, of course you should substitute inside. But if you don't have enough time, and you predicted that we will get the least value, then of course you know it's like this. So at this part we have negative slope, and right hand side we have positive slope in order to fulfill the requirement. So you may just simply say it is negative, and right hand side is positive. And if you have time, you can analyze this term. It's because this is always positive, so this determines the sign here. When t is large enough, then the outcome will become positive. When t is not large enough, then the outcome will become negative. So now, together with the table, we successfully proved that this condition, that means t is equal to 4 natural log 2. So our calculation, what is asked is the value of v in this situation. So when t is equal to 4 natural log 2, then v is equal to 64. H is 1, e power of 0.5, t is 4 natural log 2, plus 4. We just calculate this one. E power of 2 log 2, that means log 4, and then plus 4. So 64 divided by e and natural log are opposite, so 4 plus 4. We get 8. And no unit should be written down because we do not include the meter cube here. So v is just a single value, 8. In part C1, they use the same condition, and we already proved this condition. That means t is equal to 4 natural log 2. It's really useful. And then we are going to find the value of this item while they give us how we can connect s and v together. S is equal to v power of 2 over 3. You find ds dt here. Of course, we can obtain it by differentiate both sides. So I'm now going to differentiate both sides with respect to t. Left hand side, nothing we should do because it's just our target. And then the key point is right hand side because we can apply it by chain rule. We have 2 over 3 and then v power of negative 1 over 3. Differentiate. Don't forget that v and t are not the same variable, so we have to handle the chain rule. Therefore, there are 2 items you need. At t equal to 4 natural log 2, you need to get the corresponding v, which is the answer in part B3. We also get the value of dv dt when t is equal to 4 natural log 2. So we call that dv dt is equal to natural log 32 e power 0.5 t divided by e 0.5 t plus 4 whole thing square at t equal to 4 natural log 2. We explain that this part is 4. So this is negative 2. Together with the fact that we know that v when t equal to 4 natural log 2 is equal to 8. So we can draw the conclusion by using our calculation before. When our condition is fulfilled, ds dt is equal to 2 over 3. v is 8 power of negative 1 over 3. And then dv dt is negative 2. That is negative 2 over 3. In the final part, someone claimed that ds dt attain its least value when this attain its least value. So you better simplify the condition. When this attain its least value, that means when t is equal to 4 natural log 2. We already applied that for a few times. But what is the meaning of when this attain its least value? One of the conditions to fulfill this is ds dt differentiate again will give you 0. So one of the testing methods is to test, is this equal to 0 when t is equal to this? If yes, then we can use the table to further verify. If no, then we can simply reject. The claim is not correct in those cases. We call that ds dt is connected with v like this that we calculate just now. So, therefore, in order to get the second order derivative, we just differentiate once again. 2 over 3, apply product rule again. Again, by chain rule, since v and t are not the same, we have this item, and then the original dv dt at the back. We keep the first factor this time, and then we differentiate once again with respect to t, so it will become the second order. Now, our expression, there are three items. The first item, v. The second kind of item, dv dt. The last kind of item is d squared v dt squared. When dv dt attains its least value, that implies t is equal to 4 natural log 2. In this situation, v is equal to 8, just like what we calculated before. dv dt is equal to -2. And finally, the second order derivative, of course, is equal to 0. Therefore, we can get the second order derivative for s in this situation. T equal to 4 natural log 2. So it's equal to 2 over 3, -1 over 3, a is power of -4 over 3, and then -2 bracket square, and then plus 0. Just make sure you use calculator very carefully. Then we get -1 over 18. The key point is, if it really attains its least value, then the first condition is this should be 0, but this is not 0. That's why you can reject the statement. The claim is not correct.